Hello friends, let's see some divisibility rules which help us to easily test if one number is divided by another number or not. For smaller numbers, it is very easy to, by seeing itself we can say whether that number can be divisible or not. But when it comes to bigger numbers, to do the complete division, it's very time consuming. So through these divisibility tests, we can feel it easy and we can know the answer easily whether whether the number is divisible or not. What is divisible by? When you divide one number by another, the result is a whole number. That means if you are dividing one number by another number, it should be divided exactly and the remainder should be 0. That is what the meaning of divisible by. For example, 14 is divisible by 7. When you divide 14 by 7, we get the quotient as 2 and remainder as 0. That means 14 is exactly divided by 7 and we get the quotient as 2 and it's a whole number. If you see 15, it is not divisible by 7 because we get 2 1 by 7 as a quotient. That means when you divide 15 with 7, still we have remainder as 1. Okay, that means it is not exactly divided by 7. And another example is 0 is divisible by 7 because we get 0 and 0 is a whole number. Let's see divisibility rules for 1. What is that rule? Any integer, not a fraction, is divisible by 1. Any integer is divisible by 1. We all know that, but still I have to tell you the divisibility rules, and so I included this also. See, 5 divided by 1 is 5, 3 divided by 1 is 3, 15 divided by 1 is 15. Divisibility rules for 2. The last digit should be a even number. What is an even number? Any number which has the units digit as 0, 2, 4, 6 or 8. Let's see the example. 54 divided by 2. We get the remainder as 0 and quotient as 27. That is a whole number. So this rule is satisfying for 54 when we divide it by 2. So we can say 54 can be exactly divided by 2 using this divisibility rule. And you can also see that in the units place, in the ones place, 4 is the even number. Divisibility rules for 3. The sum of the digits is divisible by 3. Let's see an example to understand this. Let's take the number 381. If you add those digits, what is the sum? 3 plus 8 plus 1 equal to 12. So the answer is 12. Is 12 divided by 3? Yes, exactly. We get the remainder 0. So that means if 12 is divided by 3, then the whole number, 381, can also be divisible by 3. This is how we test for the number when we are dividing it by 3, whether the sum of the digits are divisible by 3 exactly or not. Divisibility rules for 4. The last two digits of a number should be divisible by 4. Then automatically whatever the number, however the big it is, by checking those last two digits itself, we can say whether it is divisible by 4 or not. Let's see the example. 1312. So in this number, what are the last two digits? 12. So 12 is divided by 4, and so easily we can say the 1312 number can be exactly divided by 4. What about this? Another example, 7019. These last two digits are 19 and this is not divisible by 4. So the number 7019 cannot be divisible by 4. Divisibility rules for 5. This is so simple. The last digit is either 0 or 5. Then we can divide any big number by saying itself. We can say the number is divisible by 0, 5 or not. Divisibility rules for 6. So for this we should check the units digit and it should be the even, that is one condition, and another condition is it should be divisible by 3. That means both the rules, divisibility rule of 2 and divisibility rule of 3, both should be satisfied. Let's check with an example. 114. This is an even number, we can say it by saying the last digit, and it also should be divisible by 3. How we check the divisibility of 3? 1 plus 1 plus 4, that is 6. 6 is divided by 3. So it is passing both the rules, 2 rule and the 3 rule, and so we can say the number 114 is divisible by 6. 308. It is even, but 3 plus 0 plus 8 equal to 11, and 11 divided by 3 is 3 2 by 3. That is not a whole number. 11 can't be exactly divided by 3, and so 308 can't be exactly divided by 6. Divisibility rules for 7. Double the last digit and subtract it from a number made by the another digits. The result must be divided by 7. We can apply this rule to that answer again. Let's see an example. 672. First we are doubling the last digit. Last digit is 2, double of 2 is 4. Now subtract it from the remaining digits. What are the remaining digits? 67. Minus 7 gives you 63. Is 63 divided by 7 exactly? Yes. So the number 672 is also divided by 7 exactly. Next example, 105. Double the last digit. Last digit is 5 and double 5 is 10. And let's subtract it from the remaining digits. 10 minus 10 is 0, and 0 is divided by 7? Yes, exactly. So 105 also divided by 7. Next example, 905. Double the 5 is 10. Let's subtract it from the remaining digits. 90 minus 10, that equals to 80. 80 is not exactly divided by 7. That's why 905 is not exactly divided by 7. That's how we check the number whether it is divisible by 7 or not by following these rules. Divisibility rules for 8. The last 3 digits are divisible by 8. 109816. Let's check this big number whether it is divisible by 8 or not. How? Take the last 3 digits 816 and check whether it is divisible by 8. Yes, it divides exactly and gives the quotient 102, that is a whole number. So the number 109816 is divisible by 8. Let's see next example. 216302. What are the last 3 digits? 302. Is it divisible by 8? No, it won't give the remainder 0. So 216302 is not exactly divisible by 8. Divisibility rules for 9. The sum of the digits is divisible by 9. 1629. Add all the digits. 1 plus 6 plus 2 plus 9 gives you 18. Is 18 divisible by 9? Yes. So 1629 also divisible by 9. Next example, 2013. 2 plus 0 plus 1 plus 3 gives you 6. It is not divisible by 9. So the given number 2016 is not divisible by 9 because it didn't follow our rules. Divisibility rules for 10. The number ends with 0. We all know this. You can see the examples here. 220. Last digit is 0, so it is divisible by 10. Next example is 221. Last digit is 1, so it can't be divided by 10 exactly. Divisibility rules for 11. Add and subtract digits in an alternating pattern. That means you have to add one digit, subtract one digit, add one digit, subtract one digit. You have to do like this. You can understand through this example. 1364. Take 1 and then subtract 3, then add 6, then subtract 4, gives you 0. So you got 0, and so we can say 1364 can be divided by 11 exactly. If you take 987, add 9, subtract 8, add 7, gives you the answer 8. It's not 0, remainder is not 0. So the number 987 is not exactly divided by 11. Divisibility rules for 12. The number is divided by both 3 and 4. That means it has to pass both the rules, the divisibility rule for 3 and also divisibility rule for 4. Let's see an example. 648. Let's check first whether it is divisible by 3 or not. 6 plus 4 plus 8 equal to 18. So 18 is divided by 3. And we also should check divisibility rule for 4. What is the divisibility rule of 4? We have to take the last 2 digits and check whether it is divisible by 4 or not. Yes, it is divisible, and so it is passing both the rules, divisibility rule for 3 and 4, and so the number 648 is divisible by 12. So now you came to know all the divisibility rules, right? Hope you enjoyed the video. Thank you so much for watching.